All right, so now let's just go and talk about, so we talked about our standard equation, and then we also taught our vertex form. Let's kind of go through by you applying our definition that we just talked about. Let's see if we can write up another form of a parabola. So we know a parabola and what we've just kind of gone over, and we're just going to deal right now with the basic tenets of a vertical. So let's just say I have a vertical one like this. Now, so far, we've talked about, well, we know there's a point here, which we're going to call the focus. And then we're going to have a dotted line here, which we're going to call the directrix. OK? Now, and when looking at this, all right, we have this point, the vertex, right? Here's our x and y. Now, from our vertex form, does anybody remember what was this point, the vertex? Anybody remember what the vertex was? What point was this? Does anybody remember? It's in the formula. K was part of it. K dealt with the y coordinate and h. So this is what we call h, comma, k. Right? That was your vertex. And that's going to remain the same. All right? So now there's a difference here. We have this new definition that we implied, which we call the focus. Okay? And remember that the distance to the focus to the directrix has to be exactly the same, right? We talked about that. They have to be exactly the same. So what we're going to call this distance is p. And therefore, you know that then this distance is also going to be p. Okay, and that is the distance from the vertex to the focus, or your vertex to your directrix. Okay, so let's just kind of go through some basic definitions here real quick before we even get into a formula. If I'm giving you a parabola and I give you what the focus is, or I give you the vertex, do you think you can figure out what the focus is for this vertical? You can say the focus is just going to be k plus p. Is going to be k plus p. I'm sorry. The focus is a point, so it's going to be at h, comma, k plus p. Right? H, because you're not moving it left or right at all. You're just going to be moving it up or down with your k plus p. Then our directrix is a line. And since it's a horizontal line, we're going to say y equals, and in this case, we're going to have k minus p.
Is there ever going to be a time when directrix is going to be above and focus is going to be on bottom?
Yeah, absolutely. If this was reflected down, right, then you'd have a focus down below and a directrix up top. Right now, we're just dealing with a vertical one, and yeah, that just switches over. Then you do, your directrix would be k plus p, and your focus would be k minus p. But this is just going to be a vertical one opening up. OK? Does everybody kind of follow me with this, kind of what we've gone through right here? All right, so then, now what we can do is we can draft up a formula for this by dealing with our focus and dealing with our vertex. So the formula, when you're going to have a vertical parabola. This is for a parabola that's going to be vertically. It either opens up or it opens down. And if it opens up or opens down, is going to be dependent on your value of p. If p is going to be greater than, if your value of p is greater than 0, you know it's going to open up. If p is less than 0, that means it's going to go down, right? So that means your parabola would open down. But for a vertical parabola, you're going to have x minus h squared equals, I believe it was 4p. Yep. 4p times y minus k, where p cannot equal 0. And why does p cannot equal 0? Well, obviously, ladies and gentlemen, if p cannot equal 0, then you'd have no focus, right?
And just not, I mean, is it just not less than 0?
No, p can be less than 0. What if p was negative 1? Let's put it this way. No, it just says p cannot equal 0. What if p was negative 1? Rather than going up, p would now go down. You could have the same vertex, right? What if p was negative 1 or negative 2? Then you go down 2 and up 2. So this works for all vertical parabolas where here would be your focus. So here's your distance p. Here's p. Here's p. But now, here is when p is greater than 0. Here is when p is less than 0. Does that kind of make sense, the difference? All right, your distance, the absolute value, the distance is still going to be the same. But when it's positive, it goes up. When it's negative, it goes down. So how does that relate to what we've learned before? What happens when A, notice how, what happens when your A is positive? It opens up. When A is negative, it opens down, right? Why can't, what do we say here? We also say, hey, A cannot equal 0. A cannot equal 0. Why can't A equal 0 in these equations? Because if A equals 0, then you don't have an x squared, right? Therefore, you're not going to have a quadratic. If P equals 0, you don't even have a focus, right? And if you know you don't have a focus, you can't have a parabola. All right? Yes?
If HK is the coordinate point, what's x and y? Same thing?
HK is your vertex.
Vertex.
X and y represent all of the points on your parabola. Okay? And OK, that's it. OK. So